Okay, now we are ready to start solving trig equations. So, before we start solving trig equations, what I'd like to do is remind you how to solve algebraic equations. Linear equations is what we'll start with. So, a linear equation is an equation where the highest power of x is 1. So, number 1 and number 2 are examples of linear equations. So, just as a little warm up, let's solve these linear equations. Number 1 goes like this. 6x plus 12 is negative 20. To solve a linear equation, you want to get x by itself. So we begin by subtracting 12 from both sides. So if you subtract 12 from both sides, you get negative 32 on the right side. And then you divide by 6. So I hope this is easy for you guys and that this looks familiar. You can simplify this by dividing both of these by 2, and you can get negative 16 over 3 is the simplified answer for x in that equation. This is number 2. If you have a linear equation, x is to the power of 1, but there's fractions. It is nice to get rid of your fractions, and you can do that by multiplying both sides of your equation by the lowest common denominator, which in this case will be 15. And the 15 will distribute to each term. So it goes like this. 15 over 1 times 2 over 3. Let me erase the number 2 so it's not my way. So that's like, this is just number 2. 15 over 1 times 2 over 3. 3 can go into 15 5 times. 5 times 2 is 10 over 1. This is just 10x. No more fraction. 5 can go into 15 3 times. 3 times 1 is 3 over 1 minus 3 is what I get there. 7 times 15 is 105. And so now I don't have any more fractions. That is very nice. And so many times that's a good thing to do when you're solving these. So we'll add 3 to both sides and get that 10x is 108. Then we can divide both sides by 10 to fully isolate our x. Fully isolated means the only thing next to the x is a positive 1. That's what that means, to solve for x. So we get 108 divided by 10. Again, we can divide 2 into both of those if we want, and we'd end up with 54 over 5 is the simplified answer. All right, that did not involve trig. The next ones right here are linear equations we're going to solve that involve trig. So here we go. Number 3, I'll just use this for some space. Number 3 goes like this. If we want to solve 2 sine x plus 1 equals to 0, and this is for x is between 0 and 2 pi. Here's our interval we're solving over. Okay, cool. We first solve this, we isolate, instead of x, we want to isolate the trig function, sine x. You think of this as one big variable. So first we would subtract the 1, so we'll get 2 sine x is equal to negative 1, and then this is still what we want to isolate, so we'll divide both sides by 2. We'll get that the sine of x is negative 1/2. And now we're going to do what we did in the last video. We're going to ask ourselves, where on the unit circle is the sign negative? Well, the sign is negative in quadrant 3 and quadrant 4, okay? And what value of x has a sign of negative 1/2? And so we see that there's an angle here that does, and an angle across the way here that does. If you look at your unit circle, you can figure out that this angle is pi plus pi over 6. This is 7 pi over 6. 7 pi over 6. And that this one is 2 pi minus pi over 6 is 11 pi over 6. And those are my answers to this trig equation. The reason I answered in radians is because they gave me an x. Let's do number 4. Number 4 looks like this. 2 sine x plus 1 equals 0, only this time it says for all x. For all x. Well, what is the difference here? We're still going to solve for this. 2 sine x is negative 1. The sine of x is negative 1/2. We're still going to ask ourselves, where's the sign negative in quadrant 3 and quadrant 4? What angles give us this? We're going to find the same angles, 7 pi over 6 and 11 pi over 6. And then, but it said for all x. How can we write that? Because every angle that's coterminal to this will have that same sign value. So how do we find that? We would just add and subtract multiples of 2 pi to get other ones. Same here. So this is how we answer when it says for all x. We write down our answer when x is equal to 7 pi over 6, and then we say plus 2k pi. Also, x is equal to 11 pi over 6 plus 2k pi, where k is an integer. An integer is the positive and negative whole numbers, so including 0. So since I wrote this down, I'm establishing an understanding with you guys that we know that this means an integer, so you do not have to write this statement anymore when you are answering questions like this, plus 2k pi. We know that k is an integer. All right, let's do number 5. Let me make some more space. 5 goes like this. 2 times the cosine of theta minus the square root of 3 is 0. And they want for all theta. How will we answer that? Well, first we will solve for the cosine of theta. So isolate him, just like you were isolating x. So it's 2 cosine of theta is equal to the square root of 3. We add it to both sides. Then we divide both sides by 2, and we get that the cosine of theta is the square root of 3 over 2. And then you ask yourself, where is the cosine positive in quadrant 1 and quadrant 4? Who has a cosine of square root of 3 over 2? We can find an angle here, pi over 6, or since it's theta, 30 degrees, and another one here at 330 degrees. These are our two answers, but they said for all theta. So this is how we'll answer this. Theta is equal to 30 degrees plus 360 degrees times k, where k is an integer. These are all the coterminal angles we could get. Also, theta is equal to 330 plus 360 degrees times any integer. That's for all theta. Let's look at number 6. Sometimes they don't give us answer that we can find on our unit circle. So how do we do that? This is for theta. We're only going to find the ones that are in this range. All right. Solve for cosine of theta. Isolate him. So we're going to add 3. We're going to divide by 7. We're going to use our calculator. All right. So I want it in degree mode. Last time I was in radian, so let me go down there. I'm in degree, so that's good. Let's take the inverse cosine, second inverse cosine of 3 divided by 7. And that gives us 64.6. So theta is 64.6 degrees. So let's think about this. This is our circle. Where is cosine positive? Cosine is positive here and here. So there's going to be two angles. This one is 64.6 degrees. How will we find this guy? Well, this is 360, right? And this much is 64.6. So I can take 360 minus 64.6 degrees, and it's going to give me this reference angle where it's got the same value. So 360 minus 64.6 gives me 295.4. So they wanted all the angles in this range. So we found this one and this one. So here's my answers: 64.6 degrees and 295.4 degrees. All right, that's the first 6. I'm gonna do the second little section, the middle section, in a separate video.